Hi friends, in this video we're going to talk about how to use the JSON Grafana plugin to fetch data from APIs. By the way, the whole content of this video is present in this blog post. I will leave the link of this blog post in the description, so please check out this blog post for further reading. Grafana is an awesome monitoring and alerting platform. If you don't know about Grafana, I've already made a playlist on Grafana and I will leave the link of this playlist in the description. I've already made a video on how to connect Grafana with a PostgreSQL database. Likewise, Grafana has support for many data sources like MySQL, PostgreSQL, Elasticsearch, CSV, etc. But if you have a data source which is not supported by Grafana, suppose it's some kind of proprietary historian or it's some kind of a Excel with some different formats that can't be supported by Grafana CSV plugin, then how can you integrate the data source with Grafana? One of the easiest way is to create an API server that wraps around the data source, and Grafana will call this API server for the data. So to do this, there is a plugin called JSON Grafana plugin, and you can configure this plugin as a data source and provide the URL and parameters of the API server so that Grafana will call the API for data and the data would be served from the data source to Grafana. So this is a Grafana plugin called JSON, and when you install this plugin, you can configure a data source which can fetch data from API. This is the documentation of the JSON plugin. Alright, how to install JSON plugin? You can install in 3 different ways. One way is to use the Grafana CLI. This fetches the plugin from the internet and installs it in Grafana. It's the most easiest way. You just run a command and the plugin would be installed in Grafana. And if Grafana doesn't have internet access, then you can download the JSON plugin from GitHub and then place it in the Grafana folder. And the third method would be going to the Grafana UI and just clicking the button and JSON would be installed. Alright, let's see the easiest method. Let's log into Grafana, and in Grafana, go to this menu, connections, and add new connection. And here you have a lot of data sources. Just search for a data source and you got this JSON data source from the search results. Click on the JSON data source. I've already installed the JSON data source. That's why I'm seeing this uninstall button. But for you, they will show a install button. Click on the install button and then JSON plugin would be installed. Let's see another method where we install the JSON plugin from command line. This is the Grafana installation folder. In Windows, it would be in C program files Grafana labs folder. And here you have the Grafana folder and there is a bin folder and there is a Grafana CLI. So open a command window here, run this command grafana cli.exe plugins install and the name of the plugin, and the ID of the plugin is simport JSON data source. So if you just run this command, the plugin would be installed. Alright, let's see the third method, which is installing the plugin offline. So we are going to go to the releases page, github.com/simport grafana JSON data source/releases, and here in the releases page you can download the latest release. These are the release assets, and here you can download the required files. You can just download the zip file, and after downloading the zip file you can open it in the file explorer, and there is this simport JSON data source folder. Just copy this folder and go to the Grafana installation folder, Grafana data plugins, and here you need to paste that folder. This is how you can install JSON plugin offline. In any of the 3 methods, if you install the plugin successfully, you will get a folder in the Grafana data plugins folder, and in the folder there should be the plugin files. And once the plugin is installed, just restart Grafana. Alright, we have installed Grafana JSON plugin. Let's try to configure it. So in my Grafana, I'm going to go to my connections, data sources, and I can add a new data source. And here I'm going to select the data source which I want to add. It would be a JSON data source which I have just installed. Click on the JSON data source. You can give any name. Here the name was JSON1. And here you should give the URL of the API server, and this data source would call that API server for data. So for our example, I will create an API server at the URL localhost 8080/API. There are a variety of options, like if your server supports basic authentication, you can click on this and give the username and password for the basic authentication. You can even do a lot of TLS stuff like certificates and all. And if your API is hosted in HTTPS and if you don't want the certificate verification to be done, you can even click on this skip TLS verify. And if you want to add some custom HTTP headers in the request, you can even do that. And in the end, you can save and test. If your API server is running correctly, it will give OK. Currently, my API server is not running. That's why I'm getting bad gateway. So that's how simple it is to configure the JSON plugin. Now let's talk about how to implement the API server. So we have installed JSON plugin and we have the data source. Now we need to build this API server. This JSON plugin expects the data in a particular format. So the API server should implement some endpoints that adhere to some request response formats. Let's see what those formats are. Let's go to the JSON documentation our API should implement 4 endpoints, 1 GET request and 3 POST requests. It should listen for requests at /metrics, /metric query payload options, /query, and also /. The first API endpoint is very easy. Basically, if you click on that save and test button, the JSON plugin will send a request to the /URL. In our case, it would be localhost 8080/API. And our API server should return with a 200 HTTP response. That means you can return any response, but the HTTP code should be 200. And then Grafana will confirm that the API is working. So basically, this is a health check endpoint. Now let's talk about the other 3 API endpoints to be implemented. To make it easy to understand, let's try to go for an example which I've already created. In Python Flask, I've already implemented the API server. For example, you can see at /API, it's just returning some blank string, but the HTTP status would be 200, so you'll get status OK. Now let's run this server. Now the Flask server is running. This is the API server which will listen on port 8080, and since the root is /API, it will conform to our JSON plugins requirements. Now let's go to the example we have created. In the dashboard section, I already created a dashboard called JSON plugin demo. Let's open that. And here is my sample dashboard. I'm already getting the data. Let's edit this panel. And here, let's expand this query editor. So since we have created a data source called JSON, in the drop down for the data source, I'm getting this JSON. I've already installed a PostgreSQL plugin. That's why I'm seeing this one also in the option. So we have selected the JSON plugin, and then I've created 2 queries. And let's see the first query. Here there is a drop down called metric. We have 2 metrics, history and real time. So the metric is basically the type of data you want to query from the data source. Currently, this API can serve 2 types of data. One is historical data, another is real time data. So this is not inbuilt in Grafana or the JSON data source. The API server will actually send these results. So when you click on this drop down, Grafana will send a request to the API server at this /metrics endpoint, and the endpoint will send the possible data types that can be fetched from the API server. In my case, 2 metric types, which is history and real time. Now let's see how I have implemented this metric type. You can see when I click the drop down, I'm getting this request to /API/metrics. The response is something like this. So this is the readable metric name and this is the value. If you don't provide label, the value would be displayed there. So basically at the /metrics API, you can send metrics something like this. For each metric, send the label and value. That was about the metrics endpoint. The next thing is the payload. Payload is basically the inputs you provide to the API in the JSON form. Suppose you want to fetch data from a data source and you want to give some input parameters. For example, my data source is a historian and I want to fetch data from that. By default, Grafana dashboard sends the start time and end time. But if I want to give more inputs like what point ID I want to fetch and what is the sampling rate and what is the sampling type, I need to have something to provide the inputs to the data source while data fetching. So the additional inputs that can be provided to the API can be sent through this payload. So this payload input will be used while fetching the data from the data source. So how does Grafana fetch the data from the data source? The API server should implement this endpoint called /query. A post request would be sent to /query, and in the post request body, the metric and the payload would be sent. Then the API server should do all the fetching and provide the required data in response. So let's see an example here. When you implement a query endpoint, you will get a post request body something like this. You don't need to be overwhelmed. It's really easy. Let's try to break down the request sent by Grafana to the query API endpoint. To fetch the data, you need the from time and to time. It will be present in the requests range, from, and to attributes. So extract the from time and to time from these attributes. So if the request body is something like Q, you can go to Q of range of from and it will give the from time. Q of range of to will give you the to time. And now the important thing is this targets. What is targets? In my example, I've got 2 queries. I can even add third query. So this panel is doing 2 queries to the data source. That means I'm expecting 2 time series generally. So when you click on this reload button or the dashboard automatically refreshes, the request would be sent with all these data queries. So basically targets contain each data query in the query editor. For example, here I've got 2 queries and these 2 queries would be present in this targets list. You can see this is the first object and this is the second object. So each object will contain the query information So these two attributes of the target matter. One is the payload. This will be payload of the query, and the other is the reference ID. You can use this to display the series and to give the series a name. The same way in the second target list also, I got my payload and I got my reference ID. So now we understood how the request body would be. Let's see how the response from the API endpoint should be. So for the request, the response should be something like this. Generally, for each target, we give a corresponding response target. So for the first target, the reference ID test1, I have created a target called test1, and these are the data points. The data points are what which are plotted on Grafana. The format is really simple. Each sample would be the value and the timestamp. So this is actually the timestamp. This is the Unix epoch timestamp in milliseconds. That means how many milliseconds have passed from Jan 1st 1970 UTC. So in any programming language, there are utility functions to do this. So it's not very tough. But the response from the API should contain timestamp in the Unix epoch milliseconds format. I got two targets. That's why my API will create two series, and the name of the target would be in this target. The name is test1 because the reference of the target was test1 and the reference of the second target was test2, so I kept the target as test2, and these are the data points. Now the thing to remember here is the number of targets you send is not dependent on the request. That means there can be some complex logic where you give two queries but you expect to create 6 lines out of that. That means you can create 6 targets out of it. But 99% the scenario would be like you would like to create one series for one query. So this is something like I've given two queries, that's why I'm returning two targets or two time series in return. But it's not compulsory. You can send 4 series also depending upon your use case. So once this data gets to Grafana, it will plot the data in the panel something like this. So by implementing this slash query endpoint, Grafana can talk to the data source, query the data, and get the result data in response and plot it in the panel. So that's it. Just by knowing the request response formats of the metrics endpoint and the query endpoint, you can create a functional JSON plugin data API fetching mechanism. But there is a recent interesting development in this JSON plugin where they have provided a builder. So what's a builder? In the code mode, which is a normal mode, the payload should be given by the user manually in JSON format. So in this use case, the people using Grafana are expected to understand this format. They are required to know what JSON is. They are required to know what the syntax of JSON is. But in the builder mode, Grafana makes a request to the metrics query API, and if we send the payload schema in the response, Grafana will dynamically build the inputs for the user. So I've sent the payload schema in the response. That's why I got these inputs: point ID, sampling type, sampling frequency, and avoid future. So in my sampling type, there is also a drop down where I can select the possible sampling types. And this point ID is an input where I can give whatever I want. And this is also an input. This is also a select where I can select yes or no. So let's see how it can be done. So remember the slash metrics endpoint. You can just send the metric name and label of each metric. But instead of that, along with label and value, if you send the payload schema also, then the builder can create the dynamic inputs for you. Let's see a simple example. For the same scenario, I am sending two objects in a metrics response, and in each object, there is a label and value of the metric, and there is a new attribute called payloads, and here in the payloads, I am specifying the schema of each payload attribute. Let's see the first attribute. The first attribute is point ID. I require it to be just an input field, right? So I'm telling the label is point ID, the name is basically the attribute name of the payload, and the type is input. So an input field would be created for the point ID attribute. The next payload attribute is basically sampling type. The label is sampling type, and I'm telling it a type select. That means instead of inputting manually, user can choose from options. So the options for the values can be given in this options attribute. So while mentioning the schema of the payload attribute, I'm also giving the options here. The options is also simple. It's just the option value and the readable label. And you can even give the placeholder. So if the input field is empty, this text would be visible. And there is this special attribute called reload metric. This means if you change the input for this payload attribute, again the metrics call would be made and the input fields would be reloaded. So this is really important because if you want other inputs to be based upon the current input which you have selected, you can implement that using this reload metric. Suppose if I select the snap, I want the payload schema to be 1, and if I select the option minimum, I want some other payload schema. And this is another payload attribute schema, which is avoid future, and I'm making the type as select and the label as avoid future. I did not mention yes or no here, but I got yes or no in my Grafana editor. How we did that we will discuss in a minute, but this is the first payload. The same way, this is the second payload. So we have mentioned the metric and we are defining the metric payload. The payload will have two attributes, which is the point ID and avoid future, and we are mentioning that it's of type input and this avoid future is of type select. Well, one more thing you need to remember is when a request is made to the slash metrics API endpoint, in the post request body, you will get the currently selected metric and the currently selected payload also. This can be useful for the API server to understand what is the current input provided in the query input, and it can dynamically populate the inputs based on the current input. For example, if the sampling type is snap, the API endpoint can give one payload schema, and if the sampling type is average, the API endpoint can give another payload schema. So we can make advantage of this slash metrics request body also. So this way, since my slash metrics endpoint is giving the payload schema in the response also, Grafana has dynamically created input fields for the payload attributes. If you are not sending the metric payload schema in the response, then user should use this code mode and provide the payload in the JSON format. Alright, in our slash metrics response, we did not provide the schema of the avoid future select options, but I am getting this yes and no in the options. How was this possible? Well, that's because of this endpoint slash metric payload options. For select inputs, particularly without options provided in the schema, the request would be made by Grafana to this metric payload options. It would be a post request, and the post request body would contain the current metric selected, the current payload, and the name of the attribute for which you want the options. For example, when I click on this drop down button, the request would be sent to slash metric payload options. The metric would be history, and all these payload values like point ID ABC, sampling type max, sampling frequency 120, and avoid future would be sent. That would be the payload. And next, the name would be the name of this dropdown for which I want the select values. The name would be avoid future. So the server, while handling the request, will get to know for which attributes the options are to be loaded. So if the name is avoid future, then it loads some options. If the name is some other, then it will load the relevant options in the response. For my case, when I see the name avoid future, I want to send two options, which is yes or no. And that's why dynamically Grafana, when I click this select input, since there are no options provided by default, Grafana is making a request to the metric payload options, and then the API server is returning the options dynamically. You can see this feature can be very useful if you want to dynamically populate the values based upon the inputs provided. So these are the four endpoints that needs to be provided by the API server. Slash is basically for the health check. Slash metrics is basically to populate the metrics dropdown, and slash query is basically to send the data based upon the request from Grafana. So slash query actually returns the data that is being plotted in Grafana. And if you want to create a builder for user convenience, in the slash metrics, you can send the metric payload schema based upon the dynamic input field should be shown for the user without writing the JSON. And if your metric payload schema attribute was a select type and no options were given, then a request would be made to metric payload options, and the API server would send the options dynamically while the dropdown was clicked. So these are the four API endpoints which are need to be implemented by the API server. So till now we have talked about how the request and response formats would be. So the API server should be a HTTP server listening to HTTP request and creating HTTP response. So the server can be implemented in any language until it's a HTTP server. So for this demo, I have implemented API server in Python. So this is the Python code server.py. So first I have created a Flask application, and then I'm running the Flask application at localhost port 8080 because in our JSON configuration, the server should listen at port 8080. And then the first easy endpoint was health check endpoint, which is basically at the slash. So slash API would return a simple string with HTTP status code 200, and then the slash metrics endpoint will return the metrics along with payload schema. And here the API server is smartly sending the payload schema based upon the current payload. For example, if the metric was history and the sampling type of the payload is raw, then I'm giving separate payload schema. Let's see the demo here. If the metric is history, I'm seeing the payload having point ID, sampling type, sampling frequency, and avoid feature. If I select the metric as real time, I'm just having two attributes, which is point ID and avoid future. So if I select the metric as history, I'm getting all these inputs. So based upon the current metric information sent in the request body, I'm giving the payload schema, and this is the metric payload options endpoint. So if the name was avoid future, that means the payload attribute was avoid future. The possible attributes I want to populate is yes or no. So the payload options are this yes or no, and I'm returning this payload options. That's why whenever I click on this select list, dynamically Grafana will fetch these options from the API endpoint and provide them here. And the most important endpoint is the slash query endpoint. You can say I'm getting the start time from the request body, end time from the request body, and I'm going to iterate from each target, and for each target I'm getting the payload, and based upon the start time and payload inputs I'm generating the data. For example, since it's a demo, I'm generating random data, but in your case you can get the data from your proprietary data source based upon the metric and the metric payload, and then send the response in the required format. Each sample is in the form of a value. In my case it's a random value, and the timestamp in the Unix epoch milliseconds format, and then I'm returning the response. In the response you can see the names test1 and test2 because I'm naming the output series based upon the reference ID. You can see that here target of reference ID is being given to the output data. That means if I change this as test1 to data1, the output would be data1. So the name of the series is being dictated by this reference ID. So this way we have implemented the API endpoint slash query. So that's it guys. This is how you can integrate an API with JSON Grafana plugin. Just by implementing these 4 API endpoints as per your requirement, you can integrate any data source with Grafana by creating an API server. You can see I've created a blog post on using JSON Grafana plugin to fetch API data. I've given you the nodes, commands, images, and even the Python source code to implement an API server in this blog post. So please be sure to check out the link of this blog post in the description. I've also given the link to the JSON plugin documentation so that you can do further reading about this JSON plugin of Grafana. Please ask questions or post your valuable feedback in the comment section. Hope you like this video guys. Thank you for watching. Peace.